direct variation today. It should be hopefully pretty easy when we relate it to linear equations, right, Jocelyn?
Yes.
Yes. So direct variation is a special type of linear equation. You guys are going to get that here in a minute. Okay? So go ahead and get that stuff defined. All right. Hey, what is a direct variation? Direct variation. Oh. How many of you finished defining it? Okay. What's a direct variation? Maddie?
A linear function that can be written in the form of y equals kx.
Y equals kx. Looks really similar to what equation? Y equals mx. Now, if we have y equals mx, what are we missing? B. Now, it's not that b has disappeared. It's just in this form, b is what? B is 0. So please keep that in mind when you're dealing with a direct variation, that b is 0. That would mean that m and k are they're the same. They both represent slope. It's just in a direct variation, we call it k our constant of variation. We don't really call it a slope. That's another name for slope. So if you remember back to last week when we were talking about all those different things that slope represented, well, slope also represents constant of variation. Okay? It's usually in the form of a rate. We call it a rate. I think we had that term there. Okay? So y equals kx, our direct variation function, y equals kx, is just a special type of linear equation where the y-intercept is 0. So it's very similar to what you already deal with a lot in life. You may not think it is, okay? But how many of you plan on driving here in the next couple of years? Okay, how many actually already have your permit? How many don't have your permit? Oh, the majority of the class. How many already drive? How many drive with their parents breaking the law? You're breaking the law.
Not breaking the law.
Okay, how many of you let your like you have maybe not your parents, but well hopefully your parents. They let you drive around a parking lot and you don't have a permit. Okay. That would be kind of breaking the law. All right. So, I'm just saying eventually you're going to get your permit and then eventually you're going to get your license. And when you get your license, you have these cars, most of them nowadays, that you need to put this special liquid in to make them run.
Is it gas?
Yeah, gasoline. Yeah, so you go to a station where they sell that gasoline called a gas station.
No way.
It's pretty crazy.
Oh my God.
Yeah, and at that gas station, you actually purchase this fluid to put in your vehicle. And it costs you $0 to buy this gas as long as you buy 0 gallons of it. Pretty good deal, right? If you buy none, you don't have to pay anything. Like when you pass gas stations, as long as you don't buy any gas at them, you can pass them for free. I know, you just go and you stop at the pump, look at it, go, whoa, and then keep going. Okay, some of them have little TVs there. Maybe watch some TV. Okay, but if you don't buy any gas, you don't have to pay for gas. That is a direct variation. However, if you buy 1 gallon of gas, then you may have to pay close to $4 right now. Okay? 1 gallon, $4. When I was in school, it was less than $1 a gallon. That was so cool.
Times have changed.
Yeah. Then again, minimum wage is under $5 an hour. So, all right. So I wasn't making a lot at Burgerville. All right. Anyway, that's a direct variation. That's what you guys deal with a lot right now. If you go into the store, you buy apples, and you're paying cost per pound. So if you don't buy any apples, they don't charge you anything. So it's a 0-0. If you buy a pound of apples, they charge you something. Okay, that is a special type of linear equation called a direct variation. It's the one you deal with a lot right now. Okay? How many plan on getting a job? Direct variation. Most of them, an hourly rate. If you're like, dude, I got a job. Well, how much do you work? Well, last week I didn't work at all. Well, how much do you make? I didn't make anything. Like work none and I got none. That's pretty cool, right? Okay. Well, what if you work an hour? Well, then I get like $9 or whatever minimum wage is now. $10, let's say, close to 10. Some places want it like 15, 20, 30, you know, they just want it really high. But right around here, it's about $10. Okay? So, what is it? 9.32? $9.32. And when you start earning your own money, then you really start watching what you buy. For those of you who, how many earn your own money right now? How many of you watch what you buy right now? You're like, dude, I'm not buying that pop. That cost me like 10 minutes of work. Are you kidding? Dude. Okay? All right. Right now, I want you guys to go ahead and complete those questions. Okay, in your notes, you get about 8 minutes or so. 5 Solve each equation for y. Do x and y vary directly? If so, identify the constant of variation. All right, if I'm solving for y, what do I do here?
Divide by 7.
Cassie. Divide by 7. We get y equals 2/7 x. Direct variation? How many say yes? How many say no? How many say I'm not sure? Okay, the answer is yes. Someone that said yes. Why is it a direct variation? Nick?
Because the b equals 0.
Because b equals 0. We don't see a b term. Therefore, it's a direct variation. B is 0. When your y-intercept is 0, it's a direct variation. Okay? What's the constant of variation? Jordan? 2/7. So another name for constant of variation is? Slope. What's the slope? The slope is 2/7. The constant of variation is 2/7. Okay. Letter B. First step, get y by itself. Hannah. Okay, so 3y equals, someone else? Ethan? What do you got?
8 minus 4x.
8 minus 4x, or in slope-intercept form, we put
Negative 4x plus 8.
negative 4x plus 8. All right. What does y equal there? Jaden Goodrich.
Negative 4x plus 8 or divided by 3.
Okay, negative 4x plus 8, all divided by 3, or each of these things is divided by 3. Okay. Is it a direct variation? Tell your neighbor yes or no.
No.
Okay, how many say yes? How many say no? How many say I'm not sure? Okay, it is not. Can someone tell me why it is not? Eli?
There's b.
There is a b term other than 0. Okay, b is not 0. Okay, b is not 0. All right, so the answer is no because b is not 0, or there is a b term other than 0. Okay, well, Eli's initial answer where he says there's a b term, that's not a valid answer because there's a b term here. What's the b term?
0.
0. We're going to see that again a little later. Well, actually, let me address it now. If for some reason I give you a problem, well, let's do this one. This one is y equals 7/5 or 7.5x. And I say, is it a direct variation? And you say, yep. Feel pretty confident that most of you would say yes. And then I'd say, what's the constant of variation? And you'd say 7.5 because that's the slope. And I'd say, why is it a direct variation? Because b equals 0. If you were to say, because there's not a b term, then that is incorrect. Okay, there is a b term. B is 0. Zero's our hero. Don't leave your hero out in the cold, man. Okay? Seriously, you guys, that's a hint for the type of wording I'm expecting. All right, you got to be specific. I know that we don't see a b term, but it's there. It's our hero, dude. Our hero's amazing. It can be invisible. It's got like hero-esque powers. Okay? Zero's our hero. Okay? It's back there. All right, any questions there? Okay, tell your neighbor what the answer to number 6 is.
The x and y intercepts are 0. Or equal to 0.
All right, Colby, what do you got? Okay, what do we know about where our line will cross on a direct variation? Where does it cross? Goes through a special point all the time. 0, 0. Okay, And so where's the y-intercept? It's 0. And where's the x-intercept? Yeah. Okay? It's at 0, 0. So it always goes through the coordinate 0, 0, as a matter of fact. And what do we call that coordinate?
Origin.
The origin. The x-intercept is 0, the y-intercept is 0, and it goes through the 0, 0, which is the origin. Always. That's a direct variation. Okay, so equation form, we don't see the b. Picture form, it always goes through the origin. Okay, everyone rate themselves 1 to 5 right now? Okay, let's move it on. All right, let's try number 9, Uru. Number 9, identify the slope of each direct variation. If you haven't done these already, go and just tell your neighbor. Tiffany, what do you think for letter A? 7. All right. Ethan, letter B.
-1/3.
All right. And letter C, Kaylin? 7.5. Well done. The slope, remember, is just your constant. All right. Please do not include the value x in there. All right. How many have ever done dimensional analysis? Your science teachers like to call these Frankenstein equations. How many have done that? Oh, those are so fun. Oh, yeah, I know. Okay. So all it does is it allows you to change what you're measuring in. So for instance, I have an example up here. They started in feet per hour and they ended up with inches per day. Okay, here I'm starting with cups per minute and I'm going to end up with, canceling minutes, I now have cups per second. Okay. All right, so maybe it's like milk. How many cups of milk can you drink? You know, well, I can drink 1 cup of milk in 180 seconds. All right. You shouldn't start guzzling milk. That's not good for you. Okay. How do you know the units? Well, you use cross-canceling. Now, last period when I was doing this, some of the students I had individual conversations with really mixed up they had no idea what I was doing up here with cross-canceling. So if you have questions when we go through this next example, please stop me and raise your hand. Okay, just raise your hand. Ask the questions, stop my, okay? How many think you get the canceling right now? Okay, it helps you to change units. So for instance, many of you said that here pretty soon you're going to be driving, correct? Everyone agree? Mm-hmm. Okay, eventually. So I teach drivers ed at defensive. I like to point out to students different measures, like if you're on Highway 9, the speed limit on most of Highway 9 is 55. Unbelievable. Messed up. Use a pencil. 55 miles per hour. How many knew that? You're supposed to go about 55. Okay? It fluctuates in different areas, but most about 55 miles an hour. And I like to point out, some of the dangers and hazards out there on the road, and I ask students what they're scared of. A lot are scared of police. Some are scared of parking. Some are scared of, other people. Some are scared of, spiders in their car. Who knows? Okay. I point out that I really get concerned about the highways around here because you're driving head on towards another vehicle at 55 miles an hour. They're in the other lane, I hope. Okay. And you guys are going head on towards each other at 55 miles an hour, and then if you cross that center line or they cross it, that yellow line that doesn't bounce you back, you can actually cross. Okay? If you go across and they go across, and you're assuming you're both doing the speed limit at 55, it's like hitting a brick wall at 110 miles an hour. Okay, you slam in head on at each other. That's mass destruction. And you got Highway 9, Highway 2, Highway 204, Highway 92 that goes out to the high school, one that a lot of you will drive. Or at least they put in roundabouts, but Highway 2, they count like days since the last major fatality. It's really, sad situation. Okay, well, you guys are going to be driving Highway 9, and you think about, how many of you can think of poor drivers? Someone that drives really bad. Okay, and you're going to be on the road with them, and some of you you're not too worried about it, but let me bring this more towards where you're at. Most of you walk right now, like at least to class. Okay, so miles per hour. Let's break this down to feet per second. So if I want to go from miles per hour to feet per second, I would then have to change miles to feet and hours to seconds. Well, let's go miles to feet because most of you know that measurement directly. Some of you do. Okay? How many feet are in a mile?
5,280.
Okay, 5,280 feet in 1 mile. Now, we could write it like that, or the other way we could write it is we could say there is 1 mile in or per 5,280 feet. You write it either way. Now, which one would I want to use? Top or bottom?
Top.
Why the top? Volunteer, raise your hand. Why the top? Jody?
Because you can cancel out minus.
Yeah, if you put the top here, hey, don't get distracted, please. Okay, if you put this one up here, what ends up happening is I have 5,280 feet, and I have 1 mile on the bottom. See how I timed that? Just so that the bell could ring. Okay? And I can cancel out the miles. If I would have went the other way, the mile would have been on the same level as the other mile, and I couldn't have canceled them. I'm just canceling labels right now. All right? So now I'm measuring at, if I were to multiply this, I have feet per hour. How many are with me right now?
Yeah.
Okay? Well, now I want to go feet per second. So I've got feet good, so I have to go from hours to seconds. Well, let's go hours to minute first. How many minutes in 1 hour? 60. So do I want 1 hour per 60 or 60 per 1 hour?
1 hour per 60.
1 hour per 60. Tell your neighbor why. Okay, now if you had a neighbor that goes, I don't know, then that means we really got to make sure that either they talk to me or they're asking questions or you're doing a good job at explaining to them. This, since hours are here and hours are here, they have to be on different levels. Therefore, you can cancel them. If I would have put hours down here, hours and hours, that when I multiply, that gives me hours squared. Okay? They've got to be on different levels. Okay, so now I have feet per, so feet per divided by what? Minutes. Well, I don't want minutes, I want seconds. So I need to now go from minutes to seconds. Do I do minutes over seconds or seconds over minutes?
Minutes over second.
Minutes over second. Ask your neighbor if they get it.
Yes. You get it?
Okay, how many seconds per 1 minute?
60.
60. We now can cancel minutes. On top, our label is feet. On bottom, our label is seconds. Now I kind of, my levels got mixed up. That's okay. Okay, feet and seconds. Feet per second. I'm good there. Now, this is where I think I messed up a few of the people in the other class. You could technically grab your calculator at this point and go that times that times that times that and get that. And that times that times that times that and get that, and then divide. I personally like to challenge myself in math sometimes. Claudia's falling asleep, dude. You gotta wake her up. Okay, I like to challenge myself sometimes. How many of you have seen someone fall asleep before? Okay, how many have seen someone fall asleep in a class? How many have been the person who fell asleep in class? Okay, so it's not like something you haven't seen. It doesn't mean I want everyone looking. Okay, I personally like to challenge myself. I like to actually cancel. Like when I see a 0, I know I can cancel that 0 and that 0. It's like factoring out a 10. So you don't have to do the canceling I'm doing now. I just like to work my brain. Okay, I'm canceling here. Okay, I could divide this by this. Okay, what number goes into 60 and 55?
5.
5. How many 5s go into 60?
12.
12. How many 5s into 55? 11. I can cancel here and here. I could take a 2 out. 2 goes into that 3 times, and 2 goes into that. Or cut it in half. 52 cut in half is 264. I could actually now change that to a 6 and cut this in half again.
132.
I can now cut this in half again and cut this in half again.
64.
66. I can now factor out a 3 here and a 3 here.
22.
I can now multiply 11 by 22, and the quick way is to write the number 22 and add those 2 digits up to get the middle. It's 242.
Wow. That's trippy.
And then that. That's what happens when you like read about math. You learn cool things. Okay? 242 divided by 3. Well, 3 goes into 24 8 times with 1 left over. 3 goes into, with none left over, excuse me. 3 goes into 2 0 times, so I'm left with 2/3. 80 and 2/3 feet per 1 second. That means when I look down at my cell phone for just 1 second, my car has traveled 80 feet. If you're like, dude, I got cat-like speed and ninja skills. It only takes me a half second. Well, okay, then it traveled 40 feet. A lane width is about 12 feet. Okay? It's very easy for your car to lose its track when you look away. And you may go, dude, I'm going to be the best driver ever. I'm never going to do that. And I applaud you. However, there are many poor drivers out there that are not the best drivers ever who won't choose to look at the road all the time. They'll always glance down at their cell phone. Okay? So make sure you're doing what you're supposed to. Anyway, dude, crazy. All right. That being said, let's move on to this. Oh, hold on. Any questions there? How many knew you traveled 80 feet per second when you're going 55? Of course you did. Huh. I mean, yeah, seriously, duh. All right. So answer question 12 and 13 to your neighbor real quick. You participated. Craig, what do you got? Is the direct variation always linear?
Yeah.
Yes, it is. Always?
Yeah.
Yeah, always. Is a linear function always a direct variation? No. So this one's yes. This one, it's not always a direct variation unless that linear function is... Sam?
Under what circumstances, if any,
Yeah.
so it could be yes.
Okay, under what circumstances, if any? So what is it? What circumstances?
Like if it doesn't have limit, if B equals 0.
Good, if b equals 0. If b equals 0. That's the important thing. Okay? Please make sure it's if b equals 0. It's not, the answer is not saying if there is not a b term. Okay? Or if there is no y-intercept. That's the most common test question I hear, and that answer. I give a test question at some point or a quiz question that says, is this direct variation? And they say yes or no or whatever, and they go, why or why not? And they sometimes you get like things like, because there's no y-intercept. There is a y-intercept. When you say there's no y-intercept, you're implying that your graph is either this or this. Okay?
Is that one of them has a y-intercept?
Oh, I'm sorry. Yeah, this one has a y-intercept. Thank you. It's that. Okay? That's not true, right? Everyone get that? It has a y-intercept. It's at? 0. Okay, very good. So that's the math ease behind it. I want you to take out yesterday's assignment. I want to just make sure we're good on this. So on our assignment, example side, okay, number 1, suppose you walk 3 miles per hour for as long as you wish. I love that. Dude, just as long as you want to walk. Hey, you can do it. 3 miles an hour. Let's just suppose we do that. What is the constant of variation? Tell your neighbor.
3.
3. Good. 3 is the answer. Now, what is your constant of variation? What does it represent in this? And it's not 3. Okay, 3 miles per hour. What is that called? Someone said it back there. It is a constant rate. It's a rate. Okay? Your constant of variation is a rate. All right, write an equation to model the distance d in which you walked in terms of the time t in hours you have walked. I want you guys to write that equation right now. Eli, what do you got?
Y equals 3t.
Okay, y equals 3t. Now I'll go with the 3t. It's definitely not y equals, but the t is correct. T stands for time.
Oh.
What are we missing there?
I fix
Yeah, go ahead.
my d.
D equals 3t, okay? D is your y variable, t is your x variable. You're dependent, you're independent, but we're dealing distance and time there. Okay, now all of a sudden they go into this. Well, first, any questions on those two? Seems to be usually okay there. But then we go into C. Why would they have you do this? I want you to finish reading the problem and tell your neighbor why they would have you actually complete part C. What's the purpose of it? Hey, Jaden, what do you think? Jaden D.
So that if the minutes
Yeah, why would you want it in minutes? Feet per minute. For sure, it changes to feet per minute. Yeah.
So if you don't walk for an hour, you can figure it out how long you go in a couple minutes.
Okay, so if you're not going for an hour, you just can figure out for a couple minutes. Why in the progression of this problem would they want us to change to feet per minute? Jody?
It says 45 minutes in the last one.
Yeah, it says use your equation, find the distance you walked in. 45 minutes. Okay? So notice the next piece here actually says write an equation to model the distance feet you've walked in t minutes versus up here where it's distance in miles to time in hours. So by making this conversion, canceling your miles, canceling your hours, you drop to feet per minute. How many feet per minute is that?
15,840. No, per minute.
Yeah. 3 times 5,280 divided by 60, unless you're going to
It's 264.
cancel. 264 feet per minute. That means every minute you walk 264 feet, dude. Well done. For as long as you wish. That's good. Yeah. Letter D. Everyone write their equation and use it to solve letter E. Here we go. Okay, if I'm representing distance and time this time, what's my rate? My new rate?
264 feet per minute.
264. Okay. Plug in our 45 minutes. Distance equals 264 times 45 gives me
11,880.
880. Wow. And that's feet. Right. For as long as you wish. That's pretty good. Well, or 45 minutes, I guess. Okay. All right. Any questions there? Okay. Assignment is the mixed side. All right. Mixed side. Hey, good strategy before you leave class. Always read through each set of instructions. Make sure you know how to do each set of problems before you leave. So looking through those instructions, anything you don't understand. Okay? Not
Good.
Nick and everyone else that doesn't want to ask it needs help on 9 through 13. Okay. Write the equation for a direct variation that passes through the given points. What are the two things you need to write an equation?
M, B.
M and
B.
B. If it's linear, it's M and B. What's M? Well, we might not know it, but do we know B in a direct variation? Yeah, B is always 0. That means it crosses at 0, 0. For instance, if I was doing number 10, I don't want to do 9 because it has 2, 2. Okay? Not the dress. All right? Here's number 10. If I was, you don't have to plot these, but there's my y-intercept at 0, 0. By definition, direct variation crosses there. X, 1, 2, 3. Y, 4, 5, 6, 7. My next point is right there. What is the slope of that?
3.
Craig, what's the slope here? What's my rise and run? 7/3. I go up 7 and over 3. My slope is 7/3. So if I'm writing an equation for the direct variation, it's y equals m x plus b, or plus 0, which is just this. Now, where could I have got that 7/3 from?
The point.
Yeah, it's always going to be like that because this is one of your points. No matter where you put it. If you put 2, 2 in for the next one, well, here's my line now. My rise and run is 2 over 2, or 1. My slope is 1. Okay? Y equals mx plus b. Y equals 7/3. It's just change in y over change in x. Or, in this case, y over x, because the other coordinate you're using is 0, 0. Yeah. It would be 1, yeah. Okay, so yeah, number 9 would be y equals 1x, or 2 over 2x, or just x. Good question, Nick. I'm glad you asked it.